Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back everyone. If you remember that we take the impulse momentum theorem that is called F delta T equals M delta V. As you see here, we have relationship between mass, velocity and time force. Okay, and in last session we take the relationship between force and time, and we said that when we stretch the time or exerted the time, the force will be smaller or will be shorter, like that. Okay, today we'll take that relationship between mass, velocity and time. Okay, now let me ask you a question, guys. What will happen if we increase the mass? What will happen for the time? Now the mass will, the time will increase also, decrease. Guys, as you see here, we have here direct proportional between mass and time. What does it mean? It means that when we increase the mass, we will also increase the time. Look over for this diagram here in your book, page 194. Suppose that we have two cars here, okay, and now the first one free without anything anything here, okay, but another one loaded track, or we have here a lot of things in this one. Of course, the first one will be lighter than the other one. Suppose that the mass here is 100 or 1000 kilogram, okay, the mass there will be 2000 kilogram. Okay, if you look over here, this one take shorter time to stop, okay, but the other one take more time to stop. Okay, both of them will stop at the end here, but this one takes shorter time to stop, but the other one takes more time to stop. Okay, why? Because this one is loaded, but the another one, no, it will be lighter than this one. Okay, and also guys, the distance will be the same. If this one takes shorter time, take less distance, and the other one take a longer time to stop, take more distance. Okay, the same thing with time, with distance, they are the same. Okay, now, and the same thing will happen with the velocity also. Okay, to understand the relationship between velocity and time, now let's see this video to understand that. Look over for this video and enjoy.
The simple truth about speeding is the faster you go, the longer it takes to stop. Here's a comparison. This is a car travelling at 60 kilometres an hour and braking suddenly. Here's the same car travelling at 67 kilometres an hour and braking at the exact same point. This time the car hits, still travelling at around 30 kilometres an hour. The difference could be a matter of life or death.
Velocity and time, and also between mass and time. Okay,
2240 kilogram car traveling to the west slows down informally from 20 meters per second to 5 meters per second.
Okay, look over guys. Here, that's the mass equals 2240 kilogram. Okay, and from 2, now it means that VI equals 2 meter per second, and from VI to VF equals 5 meter per second. But here guys, you have a very simple note, very important. You should look over about the direction, because the velocity and the force, both of them are vector quantity. We should to be careful for the direction. Now he said that down, formally from. Okay, now and he said that at the end here. Okay, and now down informally it slows down to west. He said that to the west. West will be negative. Okay, south also negative. Okay, now we have here like that. Okay, now west negative, east positive, north positive, south negative. Okay, now because that you put here negative and negative. Okay, complete please.
Yes.
How long
does it take to declarate?
Yes.
I will declarate in if the force of the car is 1410 to the east.
Now he said that T, he wants how long it means that he wants T, and if the F equals 8410 to the east, it means positive. Okay, be careful for the direction, please. Okay, yeah, complete. How far? Okay.
How far does the car travel during the declaration?
Yeah, he means distance, guys. He wants distance also. Okay, now let's answer this problem quickly. Okay, now very simple. Okay, now we will use the F delta T equals M delta V. Yes, question? Ask you about that T, okay? Because that here delta T equals M delta V divided by delta T down here, okay? Sorry, F down here, okay? Like that, okay? Now substitute M 2240, okay? Now delta V, be careful for this. VF negative VI, okay? VF negative 5, negative 20, okay? To be like that, guys. Be careful, okay? Now divided by F equals 8410. How much it will look over for the formula of delta x? If you remember, we take it before in the constant speed or constant acceleration. Delta x equals half VF plus VI delta T. Okay, memorize this formula. We take it before in last semester in the constant speed.
And never displacement.
Move with this and constant speed. Okay, now we will use it to find delta x. Very simple. We will substitute half VF minus 5, VI minus 20, delta T equals 4 by the calculator equals what, shabab? The end negative 50 meters, it means to the east. Negative, it means to the west, sorry, to the west. Okay, just it.